Chapter 3, Lesson 1 on fractions and decimals. The first thing we're going to look at is how to turn any fraction into a decimal. So for example, if I have 7/8, my rule to turn any fraction into a decimal is divide the numerator by the denominator. So in this case, I'm going to take 7 and I'm going to divide it by 8. Now 8 doesn't go into 7, so I have to put my decimal point, and I put a 0 here. 8 goes into 70, 8 times, 64, 6, I have to bring down another 0, 7, 56, bring down another 0, and 8 goes into 45 times. So 7/8 is the same thing as 0.875. Alright, the next thing we're going to look at is a terminating decimal. Now, a terminating decimal is a decimal that ends or terminates. So when we do our division, it actually ends. So for example, 0.3 is a terminating decimal. 1.25 is a terminating decimal. 0.46 is a terminating decimal. But we sometimes get repeating decimals. And a repeating decimal is a decimal with a repeating pattern that never ends. Alright, so for example, if I did 1 divided by 3, I would get 0.333, and it's going to keep going. Sometimes we put ... Other times we use what we call bar notation, and it shows which part is repeating. Or I might have 1, 2, 1, 2, ... 0.12 repeating. Sometimes we also have an extra part at the beginning that doesn't repeat. We might have 1, 3, 6, 6, 6, 6, ... And if I use bar notation, it would be 1, 3, 6, and the bar only over the 6. Okay, there are certain fraction and decimals that you should have memorized. I'd like for you to pause the video and take just a minute and see which of these you can fill in without using your calculator. These are all fraction and decimal combinations that you should probably have memorized, but they also should just be very familiar to you. So if you saw 0.75, you should easily know that that's 3/4, and you should be able to do that with all of these fraction and decimal combinations. Okay, now we're going to look at comparing fractions and decimals. The easiest way to do this is to make them all decimals. Decimals are easier to compare than fractions because decimals are all out of 10 or 100 or 1,000 or 10,000. So if I have 8/9 and I'm going to compare that to 15/17, the first thing I'm going to do in my calculator is 8 divided by 9. And I'm going to get 0.88 repeating. And then I'm going to do in my calculator 15 divided by 17. And I'm going to get 0.88235,294, and so on. I can just write to that 2 because I know that this is going to have another 8. And if I compare those, I have, right here I have 8 and 8, then another 8 and another 8, and then I have an 8, and then I have a 2. And so that tells me that 8/9 is bigger than 15/17. Okay, same thing over here. I'm going to do in my calculator 5 divided by 6. If it's negative, that just tells me that my decimal is negative. So I have 0.83 repeating, and then I do 7 divided by 8 on my calculator, and I put a negative 0.875. Now remember, with my negatives, whichever one appears to be smaller is really the bigger one. So I look and I say, well, I have 8, 8, and then I have a 3, and then a 7. So normally I would say my 7 is bigger, but because it's negative, it makes it smaller. So negative 5/6 is larger than negative 7/8.